So this finally brings us to quantifiers. And I'm actually going to make some more room here. So I'm going to erase all of this. I'm just going to keep this at the top. I'm going to say, recall that truth set of P of X with domain D equals set of all X and D such that P of X. So everything you plug in that makes predicate true. All right, so here we go, quantifiers. So quantifiers, remember, are a way to make statements out of predicates. And really the way you make a statement out of predicate, like a predicate's going to say something like P of X could be X is blonde, right? So P of X could be X is blonde, saying X is a blonde person. And maybe you'll say like with domain all humans. So I'm saying that P of X and the predicate X is blonde, and things you want to plug in is any person, because that would make, that's fine. I could have also said this class, or just America, or I could have said just me and my celebrity crush. But anyway, the point is, it's ever changing. I think she is blonde at the moment. But the point is, so this is a predicate, and it becomes a statement if you plug in something for X, right? Or you plug in multiple things for X, it can become a statement. So a quantifier is a way to make this a statement by making some claim about which things you can plug in to make P of X true. We'll get to this. This will make sense once we do examples. So quantifiers. Specify I'll say how much of domain we're claiming makes predicate true. That's a very informal way of saying it, and barely even grammatically correct. But that's why we have, oh wow, that's why we have a quant here, right? Quantifier sounds like numbers, it sounds like quantity, right? And so that's the quantity, how much, right? Specifies the quantity of the domain we're claiming makes the predicate true. And so the two big types of quantifiers we have are the universal quantifier wow. I need to go to underlining school. There we go. The universal quantifier, I don't think I can get in to nail the essays. So it's just, we have the universal quantifier, which looks like that, and the eggs. That's an accident, but I like it. The existential quantifier. I'm doing math for too long. The existential quantifier, which looks like a backwards E. And remember, this means for all, and this means for some. You guys see that? Am I on the screen still? I think I am. Well, I'm off the screen, aren't I? This means for some. There we go. For all, for some, or this means for every, for each, something like that. This means for some, there exists, there is some, there's at least one, all that. I think you kind of get where this is at. So, for example, if we had the statements for all x in dogs, x goes to heaven. What is this saying?
All dogs go to heaven.
It's saying all dogs go to heaven, right? This in English is saying all dogs go to heaven. It's a nice sentiment. It looks even nicer in logical symbols. Yes, for all x in dogs, x goes to heaven. That just means that for all x in the domain dogs, this predicate, the predicate here is x goes to heaven, is true. So you can think of this as being like a p of x right here. And you think of this as being d, this statement can be rewritten for all x in d, p of x. Make sense? And so this right here, for all x in d, p of x, this is important. This is what we call a universal statement. And notice here we said quantifiers specify how much domain we're claiming is true, makes the predicate true. Well, here we're saying a certain portion of the domain makes the predicate true. We're saying for a certain portion of the domain, p of x is true. What's the portion of the domain we're saying is true? All of it. We're saying the entire domain, you can plug into p of x and make it true. So universal quantifier, it's right here. This is a example of it. And now let's define, my notes. Let's define a universal, I don't even need notes. But this one is a universal statement. I peek at my notes. Yeah, so a universal statement is any statement with the following form for all x in d, p of x. I heard static. Is there a question? Is there engagement? No? Gosh. That PR team's gonna hate me. So few tweets on this video. Oh yeah, so for all x in d, p of x, right? This is just by definition what a universal statement is. The reason we call it a universal statement is because you're making a statement about the entire universe of d. The statement you're making is for the entire universe of d, p of x is true. Think it's real simple. Think that makes sense. And we did the dog example, and we did, look at your notes from last time, we did like 6 or 7 examples last time. That might be a little generous. It was like 2 or 3. But the point is, there's a lot. So this is a universal statement right here. Any questions on what this statement means? Good. That means I've been sufficiently redundant. So it's necessary that I move on. So,